Welcome to Sleeping Researcher, a place where science narration gently guides you into restful sleep. Here, we explore fascinating ideas and discoveries with a calm, steady voice, designed to soothe your mind and ease you into tranquility. Before we begin, if you enjoy this quiet journey through science, please consider liking the video and subscribing to Sleeping Researcher. Your support helps us continue creating peaceful, educational content that blends curiosity with relaxation. Tonight, we will delve into one of the most profound mysteries of our universe, the Great Filter, and why, despite the vastness of space, we have yet to encounter any signs of alien life. This question has puzzled scientists and thinkers for decades. If the universe is so immense, filled with countless stars and planets, why does it seem so empty? Why are we alone, or at least seemingly so? The Great Filter is a concept that tries to explain this silence. It suggests that somewhere along the path from simple life to advanced civilizations, there is a barrier so difficult to overcome that very few, if any, species have made it through. Tonight, we will gently explore what this filter might be, how it shapes our understanding of life beyond Earth, and what it means for our own future in the cosmos. So, settle in and allow your mind to wander slowly through the quiet vastness of space as we uncover the mysteries of the Great Filter together. Imagine looking up at the night sky, where countless stars shimmer like distant lanterns in an endless sea. Each of these stars, many similar to our own sun, could be accompanied by planets, some perhaps harboring the conditions necessary for life. The vastness of the cosmos is staggering, and with billions upon billions of such stars scattered across the Milky Way alone, it seems almost inevitable that intelligent life should have arisen elsewhere. Yet, despite decades of searching and listening, there remains a profound silence. This silence gives rise to one of the most intriguing questions in modern science and philosophy. If the universe is so vast and old, where is everybody? This question, famously known as the Fermi paradox, highlights the puzzling contradiction between high estimates of the probability of extraterrestrial civilizations and the complete lack of evidence or contact with such civilizations. What might explain this profound cosmic quiet? One of the leading ideas proposed to address this puzzle is the concept known as the Great Filter. The Great Filter suggests that somewhere along the path, from simple atoms to advanced, spacefaring civilizations, there exists a significant barrier or series of barriers that prevent most life forms from reaching the stage where they can communicate or travel across the stars. This filter could lie behind us in the earliest steps of life's emergence, or far ahead in the future of any civilization that manages to develop intelligence and technology. The notion of the Great Filter forces us to consider the rarity or fragility of life's evolution and the immense challenges that must be overcome for a society to survive long enough to be noticed. Understanding where this filter lies could fundamentally reshape our view of life in the universe and the fate of humanity itself. The Great Filter may take many forms, each representing a critical hurdle in the development of life. It could be the initial spark of life from non-living matter, an event so unlikely that it rarely occurs even under seemingly favorable conditions. Alternatively, it might be the transition from single-celled to complex multicellular organisms, a leap that took billions of years on Earth and might be exceedingly rare elsewhere. Even if life becomes intelligent, the filter could manifest in the form of self-destruction through environmental collapse or technological disaster, preventing civilizations from reaching out to the stars. This perspective invites a sober reflection on our own history and future, highlighting the delicate balance necessary for sustained progress and survival. Each possibility carries profound implications for our understanding of the cosmos and our place within it. The absence of detected extraterrestrial intelligence might also be explained by the vast distances and timescales involved. Civilizations could arise and fall in different eras, or be separated by such immense reaches of space that communication and travel become nearly impossible. Even if many civilizations exist or have existed, the Great Filter may make the window for contact extraordinarily narrow. This means that while the universe may be teeming with life in some form, the conditions required for us to detect or interact with such life remain elusive. The silence we observe is not necessarily an absence of life, but perhaps a reflection of the profound challenges any civilization must overcome to bridge the cosmic gulf. This understanding leads us deeper into the mystery surrounding the Fermi paradox and the search for answers. The Great Filter is a concept that emerges from the contemplation of why, despite the vastness of the universe and the apparent abundance of potentially habitable planets, we have yet to encounter clear evidence of extraterrestrial civilizations. It suggests that there exists a series of highly improbable and challenging steps in the development of intelligent life that act as a kind of cosmic obstacle course. These hurdles may be so difficult to overcome that very few, if any, civilizations manage to pass through them all. This idea helps to explain the profound silence we encounter in the cosmos, often referred to as the Fermi paradox, the contradiction between the high probability of alien life and the lack of observable contact. The Great Filter implies that at some point, somewhere along the evolutionary path, there is a bottleneck that drastically limits the emergence of technologically advanced societies capable of communication or interstellar travel. This perspective invites us to consider the fragile and rare nature of our own existence and the immense challenges that lie ahead for humanity itself. To understand the Great Filter more clearly, it is helpful to think of the stages that life must pass through before becoming a spacefaring civilization. These might include the formation of simple life, the transition to complex multicellular organisms, the development of intelligence, and the ability to create technology. Each stage could present its own deep uncertainties and existential risks. For instance, the leap from simple, single-celled life to complex creatures is not guaranteed, and it may require a unique set of environmental conditions. Similarly, intelligent life capable of manipulating its environment and communicating across vast distances may be extraordinarily rare. The Great Filter suggests that somewhere along this chain, the likelihood of progressing further dramatically decreases. It is this narrowing pathway that may explain why, despite the age and scale of the universe, we find ourselves seemingly alone, or at least isolated in our search for company. This highlights how delicate and precious the emergence of advanced civilizations may truly be. The Great Filter also invites reflection on where humanity currently stands in this cosmic journey. If the filter lies behind us, it may mean that our very existence is a rare triumph over enormous odds. In this case, the silence of the universe could be a testament to the difficulty of reaching our current stage of development. On the other hand, if the filter lies ahead, it suggests that formidable challenges still await us, perhaps in the form of technological, environmental, or social obstacles that could prevent sustained advancement or survival. This possibility adds a layer of profound responsibility to our exploration of space and the future of civilization. We might be the first to reach this stage, or among the few to have done so, navigating a universe that is indifferent and formidable. Considering the Great Filter in this way deepens our understanding of the cosmic context in which we exist and the uncertainties that frame our future. The idea of the Great Filter encourages us to look outward and inward simultaneously. Outward, it challenges scientists and explorers to continue searching for faint signs of life and intelligence beyond our planet, to better understand whether the filter is a distant barrier or something we have already passed. Inward, it prompts reflection on the vulnerabilities and strengths of human civilization, emphasizing the importance of stewardship, innovation, and cooperation to overcome potential existential threats. The concept bridges the vast scales of cosmic time and space with the immediate concerns of survival and progress here on Earth. It is a sobering and inspiring notion that the silence we perceive may be not just a void, but a profound cosmic mystery awaiting further discovery. This sets the stage for exploring the possible locations of the Great Filter and what it might mean for the search for extraterrestrial life. The journey toward understanding the Great Filter begins with the earliest chapters of life itself. In the vast expanse of the cosmos, the formation of life may not be as simple or as inevitable as it might seem from the vantage point of Earth. The conditions required for life to emerge, liquid water, a stable climate, the presence of essential chemical elements, are extraordinarily delicate and finely balanced. Even on our own planet, life arose from a complex interplay of geological and chemical processes that may have taken millions of years to coalesce. This raises a profound question. If these conditions are so specific and fragile, could it be that the emergence of life is an exceptionally rare event in the universe? Such rarity would suggest that Earth's biosphere is not just a fortunate accident, but a precious anomaly in an otherwise lifeless cosmos. The implications of this possibility ripple outward, inviting us to reconsider how we frame the search for extraterrestrial life and the silent skies above us. Scientific inquiry into the origin of life, known as abiogenesis, struggles with the immense complexity involved in transitioning from non-living chemistry to self-replicating organisms. The earliest known life forms on Earth were microscopic, single-celled organisms that lacked the complexity we associate with plants, animals, or even viruses. Yet, these humble beginnings set the stage for billions of years of evolutionary innovation. The question remains, How often does this leap from simple molecules to living cells occur elsewhere? Our current understanding, while incomplete, hints that this transition may be a rare and delicate threshold. If this is true, then the so-called Great Filter may lie at these very early stages, preventing life from arising frequently in the universe. This reframes the silence in the cosmos not as an absence of intelligent civilizations, but as a scarcity of life itself, an idea both humbling and profound. This perspective directs our attention to the fundamental chemistry of the cosmos and the unique conditions that allow life to take hold at all. Considering the rarity of life's emergence encourages a deeper appreciation for Earth's singular environment. The planet's magnetic field shields it from harmful cosmic radiation, while its distance from the Sun allows for a temperate climate conducive to liquid water. These factors, combined with the presence of organic molecules and a stable atmosphere, create a rare cradle for life to flourish. Yet even with these ideal conditions, the path from chemistry to biology remains shrouded in mystery. The Great Filter hypothesis invites us to contemplate whether this step, so fundamental to all subsequent complexity, is an immense hurdle for all potential life-bearing worlds. If so, Earth may represent one of the very few places where life managed to ignite, making our existence extraordinarily precious and fragile. This realization deepens the mystery of the cosmic silence and shapes the ongoing search for life beyond our solar system. As we gaze toward distant stars and their orbiting planets, the question of life's rarity becomes even more poignant. Exoplanet discoveries have revealed a multitude of worlds, some within habitable zones where liquid water could exist. Yet the absence of clear signs of life or advanced civilizations, commonly referred to as the Fermi paradox, may be explained if the Great Filter resides in these early stages of life's formation. It suggests that while planets may be plentiful, the spark of life is an elusive flame, one that fails to ignite in most cases. This challenges the optimism of expecting to find abundant life in the galaxy, and instead invites a more cautious and patient approach to exploration. Our instruments and missions may yet uncover subtle clues, but the silence hints at a universe where life itself is a rare jewel, hidden in the vast cosmic darkness. This thought leads naturally to considering what other filters might lie ahead on the path to intelligent life. One of the most compelling areas of scientific inquiry in understanding the Great Filter involves the study of abiogenesis, the process by which life arises naturally from non-living matter. Research in this field seeks to uncover the precise conditions and chemical pathways that might have allowed the first simple organisms to emerge on early Earth. Among the leading theories is that life may have originated in hydrothermal vent environments where mineral-rich, superheated water interacts with the ocean floor. These vents provide a unique setting, offering the right combination of energy, chemical gradients, and protective niches that could foster the formation of complex organic molecules. Studies have shown that under such conditions, amino acids, nucleotides, and other life's building blocks can form spontaneously. This growing body of empirical work grounds much of our speculation in observable phenomena and laboratory simulations, reminding us that the transition from chemistry to biology is not merely a philosophical question, but one that can be approached with rigorous scientific methods. In exploring abiogenesis, researchers have also focused on the role of catalytic surfaces, such as mineral clays, which may have acted as scaffolds for assembling the first self-replicating molecules. Experimental evidence suggests that these surfaces can concentrate organic compounds, facilitating their interaction and polymerization into RNA-like strands. RNA is particularly intriguing because it can store genetic information and catalyze reactions, potentially serving as a precursor to DNA-based life. Such discoveries provide plausible pathways for how life might begin, yet they also highlight the fragility and rarity of these processes. Even on Earth, where the conditions were presumably favorable, the emergence of life was not instantaneous, but likely required millions of years of favorable circumstances and countless trials of molecular combinations. This notion supports the idea that the Great Filter may lie at this early step, abiogenesis itself, making the widespread existence of life elsewhere far from guaranteed. Beyond the laboratory, the search for biosignatures in our solar system reinforces the importance of understanding abiogenesis. Missions to Mars, Europa, and Enceladus focus on detecting organic molecules or chemical imbalances suggestive of biological activity. Yet, despite decades of exploration, no definitive signs of life have been found. This absence strengthens the hypothesis that life's origin is an exceptionally rare event, one that requires a confluence of specific and perhaps uncommon conditions. It is a sobering realization that, even if many planets possess water and energy sources, the subtle chemistry that transforms inert matter into living systems might be an extraordinary cosmic hurdle. This scientific perspective tempers our expectations and encourages patience as we refine our tools and expand our reach in the quest for life beyond Earth. The implications of abiogenesis research extend deeply into our understanding of the Great Filter's role in the cosmic narrative. If the emergence of life itself is the major bottleneck, then it explains why the universe appears so quiet and devoid of advanced civilizations. After all, before a species can evolve intelligence, technology, or interstellar communication, it must first arise from the primordial soup, a step both fundamental and precarious. This perspective challenges any assumptions that life is abundant or easily replicated across the cosmos. Instead, it suggests a universe where the vast majority of planets remain sterile, their potential unrealized. As we continue to study and simulate early Earth-like conditions in the lab, each new insight brings us closer to understanding the profound mystery of life's origins and the filters that shape our cosmic story. Once life has begun in its most basic form, the journey toward complexity remains a formidable challenge. The transition from single-celled organisms to multicellular life represents an evolutionary leap that is far from trivial. On Earth, this transition required not only the cooperation of individual cells, but also the development of intricate communication systems, cellular specialization, and mechanisms to maintain the integrity of larger biological structures. These innovations unfolded over hundreds of millions of years, suggesting that the conditions fostering such complexity are both rare and delicate. This period of evolutionary history could very well serve as a significant filter, one that few worlds ever pass. The emergence of multicellular organisms opened the door to a rich tapestry of life forms, yet it did not guarantee the eventual rise of intelligent beings. Many planets could host simple life that remains locked in microscopic simplicity, unable to navigate the evolutionary hurdles toward complexity. Environmental stability, energy availability, and genetic innovations all interplay in this delicate dance. The Earth itself endured dramatic shifts, including mass extinctions and drastic climate changes, which repeatedly tested the resilience of evolving life. This resilience, coupled with the right conditions, allowed complexity to flourish here. But such a sequence may be an extraordinary cosmic accident rather than a common outcome. Understanding this bottleneck sheds light on why the cosmos might seem so silent. If the step from single-celled to multicellular life is exceptionally difficult, then the universe may be teeming with simple organisms that never advance to more complex stages. This limitation implies a universe rich in potential, but sparse in technological civilizations. The intricacies of cellular cooperation, how cells avoid selfish behavior to form a unified organism, highlight the delicate balance required for complex life to even appear. Such biological innovations are not guaranteed outcomes of evolution, but rather rare, contingent events that could easily fail on most worlds. This perspective aligns with what we know about Earth's own history, where complex life took billions of years to emerge after the first single-celled organisms appeared. It is a reminder that the path to intelligence and advanced technology is a slow and uncertain process, not a straightforward inevitability. As we continue to explore exoplanets and deepen our understanding of biology, we might find many worlds where life has begun but remains in a microbial state, held back by this great evolutionary hurdle. Recognizing this possibility invites a humbler view of our place in the universe and the rarity of the conditions that made us possible. With this in mind, the challenge of complex life becomes a profound chapter in the story of the Great Filter. It invites us to consider that the silence we observe is not simply a matter of distance or technology, but a reflection of a fundamental cosmic bottleneck. The next steps in this inquiry naturally lead us to examine the emergence of intelligence itself and the subsequent hurdles that civilizations must overcome to become detectable across the vastness of space. The Cambrian explosion, a remarkable event approximately 540 million years ago, represents one of the most significant leaps in the history of life on Earth. In a relatively brief geological period, the planet witnessed a sudden diversification of multicellular organisms, giving rise to most of the major animal phyla we recognize today. This rapid proliferation of complex life forms suggests that evolutionary progress can sometimes happen in bursts rather than through a steady, gradual process. Yet, such moments appear to be exceedingly rare and contingent on a precise combination of environmental, genetic, and possibly even random factors. The fragile nature of these conditions hints at why complex life might be scarce in the universe. If the emergence of advanced organisms requires such a delicate balance, the Great Filter could very well reside in these early evolutionary bottlenecks, where only a handful of lineages manage to survive and flourish, while countless others fade into oblivion. Evolutionary bottlenecks, periods when species face drastic reductions in population size and genetic diversity, further illustrate the precarious journey toward complexity. These bottlenecks can result from catastrophic events, climate shifts, or ecological upheavals that threaten the very existence of life forms. For example, the Permian-Triassic extinction wiped out an estimated 90% of marine species, resetting the evolutionary landscape and limiting the options available for subsequent diversification. Such episodes underscore the vulnerability of life's progress, where even well-established organisms are not guaranteed continued survival. It is conceivable that on countless other worlds, similar or even more severe bottlenecks have thwarted the rise of complex, intelligent life. The silence we perceive from the cosmos may reflect the rarity of surviving these evolutionary gauntlets, where many potential civilizations never pass the critical thresholds necessary to reach technological maturity. Moreover, the path from simple life to intelligence is not only punctuated by mass extinctions and rapid diversification, but also by the intricate dance of genetics, environment, and chance. The Cambrian explosion itself remains a subject of intense study, with scientists still unraveling why it happened when it did, and why similar bursts have not repeated on the same scale. This enigmatic nature of pivotal evolutionary events suggests that the emergence of complex life is not an inevitable outcome, but a fortunate anomaly. If such leaps require an extraordinary confluence of factors, then the Great Filter may be hiding in these rare evolutionary milestones. The universe, vast and ancient, may host many planets with microbial life, yet only a precious few might ever witness the spark that ignites intelligence and civilization. Considering these fragile and rare evolutionary steps casts new light on the Fermi paradox, the question of why, despite the seeming abundance of habitable planets, we have yet to detect signs of extraterrestrial intelligence. The Great Filter might not be a single event, but a series of formidable barriers, each requiring a perfect alignment of conditions to overcome. The Cambrian explosion and the evolutionary bottlenecks that followed illustrate just how many such barriers exist, where life's progress can easily be halted or diverted. This perspective encourages us to view the emergence of complex, communicative civilizations as a delicate and extraordinary phenomenon, rather than an expected consequence of life's presence. As we continue to contemplate the Great Filter, our attention naturally turns toward the challenges that intelligent species face beyond biological evolution. Once life achieves complexity and intelligence, there remain profound obstacles to survival and advancement: environmental threats, self-inflicted dangers, and the vast scales of time and space that separate civilizations. Understanding the rarity and fragility of life's evolutionary milestones deepens our appreciation for the difficulties that lie ahead in the cosmic journey. It is within this context that we begin to explore the subsequent hurdles that civilizations must overcome to become visible across the void, and why the universe might still appear so silent despite its apparent potential for life. The emergence of intelligence marks a profound shift in the story of life. Among the countless forms of life that have existed on Earth, only a few have developed the cognitive capacities necessary for abstract thought, problem solving, and the use of tools. This leap is not simply about survival through adaptation, but about a new way of interacting with the environment, one that allows for intentional modification and control. Tool use in particular represents a critical turning point, enabling species to extend their physical capabilities and manipulate their surroundings with increasing sophistication. However, the evolution of such intelligence and technological ability is neither guaranteed nor inevitable. It requires a delicate balance of environmental conditions, genetic variability, and chance events that shape the trajectory of a species over millions of years. While life itself may be relatively common, the specific pathway leading to intelligent tool users is likely fraught with complexity and fragility, making this stage a potential great filter in the cosmic timeline. Beyond the mere appearance of intelligence, the development of technology capable of altering environments on a planetary scale introduces new dimensions of vulnerability. Civilizations must navigate the paradox of progress, where advancements bring both opportunity and risk. The mastery of fire, metallurgy, agriculture, and eventually energy harnessing requires an intricate understanding of natural systems, yet also exposes societies to the dangers of resource depletion, environmental degradation, and conflict. The history of human civilization itself offers a glimpse into these challenges, underscoring how fragile the balance between growth and sustainability can be. Moreover, the transition from isolated tool use to a civilization capable of interstellar communication or travel may represent an even more formidable hurdle. Each incremental step demands cooperation, resilience, and foresight, qualities that may be rare or easily lost. This delicate interplay hints at why intelligent life, capable of signaling its presence, might be an exceedingly uncommon phenomenon. The vast stretches of time required for intelligence to evolve and for technology to develop further compound these difficulties. Even if a species crosses the initial threshold of intelligence, maintaining and advancing that knowledge through generations is no small feat. Catastrophic events, whether natural disasters, climate shifts, or self-inflicted crises, can abruptly end or reset progress. The window during which a civilization might be detectable across interstellar distances could be relatively brief in cosmic terms. This temporal constraint narrows the opportunity for contact or observation, further explaining the apparent silence of the universe. Additionally, The immense distances involved mean that even successful civilizations could remain isolated, their signals diluted or delayed beyond recognition. The combination of these factors paints a picture of intelligence and tool use as not only a remarkable evolutionary achievement, but also as a fragile and fleeting phase in the cosmic saga. We begin to see how this rarity and transience might contribute to the enigma of the missing extraterrestrial voices. Considering the emergence and challenges of intelligent tool users leads us to reflect on the nature of communication and detection itself. Interstellar signals require not only the technological means to send and receive, but also a shared understanding or motivation to reach beyond one's own world. Civilizations may choose isolation, fail to develop long-range communication, or simply perish before making their presence known. The silence could be a reflection of these choices or limitations, rather than the absence of life altogether. It invites a humbling meditation on the scales of ambition and caution that may govern the fate of intelligent species. The great filter, in this sense, may reside not only in the biological or technological realms, but in the social and philosophical decisions that shape a civilization's trajectory. As we ponder these possibilities, we prepare to explore the subsequent stages of cosmic evolution and the factors that may further obscure our view of life beyond Earth. When we turn our gaze inward toward the rich tapestry of life on Earth, we find a striking disparity in the development of intelligence among species. Despite millions of years of evolution, only a handful of creatures have demonstrated the capacity for advanced cognition, tool use, and complex social structures. Studies in animal intelligence reveal that while many species exhibit remarkable problem-solving skills and communication abilities, the leap to profound, sustained technological innovation remains exceedingly rare. This rarity suggests that intelligence, as we understand it, is not simply a natural outcome of evolution, but rather a delicate convergence of numerous factors: biological, environmental, and social, that few species successfully navigate. Such findings provide a valuable lens through which to consider the great filter, a hypothetical barrier that may explain the silence we perceive in the cosmos. If advanced intelligence is so infrequently achieved on our own planet, it stands to reason that the path to technological civilizations elsewhere could be equally narrow and fraught with obstacles. Research into the cognitive capabilities of animals, from primates to cetaceans and corvids, highlights the incremental nature of intelligence and the often fragile conditions required for its emergence. Many species possess specialized skills honed for survival in their particular niches, yet these do not necessarily translate into the kind of abstract reasoning or future planning that underpins technological progress. For example, while some primates use simple tools and demonstrate cultural transmission, this behavior rarely evolves into the creation of complex machinery or written language. This suggests that intelligence alone is insufficient. It must be paired with environmental pressures, social complexity, and perhaps even chance events that encourage innovation and communication over generations. In the cosmic context, Such stringent requirements may form one of the great filter's many layers, hindering the rise of civilizations capable of interstellar communication or travel. Furthermore, the study of animal cognition emphasizes the importance of communication systems that extend beyond immediate survival needs. Language and symbolic thought enable the sharing of knowledge across time and individuals, effectively building a collective intelligence that can propel a species forward. Yet, on Earth, such advanced communication is found in only a few species, most notably humans. This rare convergence raises the question of how often such a combination arises elsewhere in the universe. The silence we observe among the stars may be less a sign of empty space and more a reflection of the rarity of these cognitive milestones. The Great Filter could thus represent a bottleneck at the level of intelligence itself, where the leap from simple awareness to sophisticated civilization is a profound and unlikely event. Insights from cognitive science also remind us of the vulnerability of intelligent species. Even after surpassing initial biological hurdles, civilizations must sustain themselves through complex social structures and overcome existential risks, environmental changes, resource depletion, or self-inflicted catastrophes. The delicate balance required for intelligence to flourish and endure may be as much a matter of social and philosophical evolution as of biological capability. This perspective expands the Great Filter beyond mere survival or technological prowess, encompassing the choices and values that determine whether a civilization persists long enough to reach out into the cosmos. Such reflections deepen the mystery of the cosmic silence and invite us to look beyond technology alone as we seek to understand our place among the stars. As we contemplate the subtle interplay of factors that govern the rise of intelligence, from neural complexity to cultural sophistication, we prepare to examine the subsequent stages in the cosmic journey. The Great Filter may lie not only in the origins of intelligence, but also in the challenges that await civilizations as they attempt to expand beyond their home worlds. These challenges could include technological sustainability, interstellar travel, and the long-term preservation of knowledge and cooperation. Understanding the delicate path from cognition to cosmic presence offers a humbling perspective on why we may yet stand alone, listening quietly for a signal that has not come. We now turn our attention toward these next steps in cosmic evolution, seeking to unravel the forces that may cloak the universe in silence. As we consider the vastness of the cosmos, it is tempting to imagine that intelligent life might be common, scattered among the countless stars that fill the night sky. Yet the reality may be far more complex. The emergence of intelligence, while remarkable, is only one step in a series of evolutionary and technological hurdles that a civilization must overcome to become detectable across interstellar distances. The transition from simple biological awareness to a technologically capable society capable of communicating beyond its own planet involves a delicate balance of environmental stability, resource availability, and social cohesion. Many worlds may harbor life, but far fewer will nurture the conditions necessary for technology to flourish and endure. This rarity challenges our assumptions about cosmic proliferation, and urges us to explore why we have yet to observe clear signs of other civilizations. The question emerges: how often does intelligence truly lead to technology that can bridge the vast gulf of space? At the heart of this inquiry lies the concept known as the Great Filter, a theoretical barrier or series of barriers that prevent most life forms from reaching advanced technological stages. These obstacles might be biological, such as the leap from single-celled to multicellular organisms, or they might be social and technological, such as the development of sustainable energy systems or the avoidance of self-destruction. Each filter represents a critical point where many civilizations could falter and disappear without leaving a trace. It is conceivable that the rarity of long-lasting, spacefaring civilizations arises because these filters are extraordinarily difficult to pass. Even if intelligence arises, the path to creating and maintaining technology capable of interstellar communication may be fraught with hazards, from environmental catastrophes to internal conflicts. Thus, the silence of the cosmos might reflect not an absence of life, but rather the infrequency with which civilizations successfully navigate these treacherous thresholds. This perspective reshapes our understanding of cosmic loneliness, highlighting the fragility of our own technological existence. Another factor to consider is the temporal window during which a civilization can actively communicate across space. Technological societies may only emit detectable signals for relatively brief periods before evolving beyond such means or succumbing to extinction. The speed of technological advancement could lead to transitions from radio waves to more subtle or efficient forms of communication that are difficult for us to detect. Alternatively, civilizations might self-limit their transmissions due to concerns about security or resource conservation. This ephemeral nature of communicative technology further narrows the chances of overlap between civilizations, making our current era an extraordinarily rare moment of mutual detectability. The vast distances between stars, combined with the finite speed of light, mean that even if signals are sent, they may take centuries or millennia to arrive, and the originating civilization might no longer exist when the message is received. These considerations deepen the enigma of silence in the night sky and challenge us to refine our search strategies. Beyond technological hurdles, the preservation of knowledge and cooperation within a civilization plays a crucial role in its survival and capacity to communicate. Societies must overcome internal challenges such as political instability, resource depletion, and cultural fragmentation to maintain the collective effort required for long-term space exploration and communication. The endurance of a civilization is not solely dependent on its technological prowess, but also on its ability to foster unity and shared purpose across generations. Failures in these areas could lead to societal collapse before meaningful contact with other civilizations is achieved. This adds a profound human dimension to the Great Filter, reminding us that the journey toward cosmic connection is as much about social evolution as it is about scientific discovery. In this light, the silence may be a testament to the extraordinary difficulty of sustaining the delicate balance necessary for cosmic dialogue. As we continue to explore the mysteries of technological civilizations and their rarity, we are reminded that the absence of evidence is not necessarily evidence of absence. The Great Filter invites us to reflect on the precariousness of our own place in the universe and the immense challenges that lie beyond the emergence of intelligence. It is a humbling reminder that the path from cognition to cosmic presence is narrow and fraught with peril. Our quest to understand why the cosmos appears so silent encourages us to look inward, examining the choices and circumstances that may determine whether humanity transcends its own great filter. With these reflections, we prepare to delve deeper into the implications of this cosmic silence and the prospects for future exploration. To grasp the vastness of the question concerning alien civilizations, scientists have turned to a remarkable tool known as the Drake equation. Conceived in the mid-20th century by astronomer Frank Drake, this equation offers a structured way to estimate the number of active, communicative extraterrestrial civilizations within our galaxy. It does so by breaking down the problem into a series of factors, each representing a step in the development of life and intelligence. These factors include the rate of star formation, the fraction of stars with planetary systems, the number of planets that could potentially support life, the fraction where life actually arises, the fraction where intelligent life develops, the fraction of civilizations that develop detectable technology, and finally, the length of time such civilizations release signals into space. By multiplying these terms, the Drake equation provides a means to transform the abstract question of alien life into a quantifiable estimate. It is important to note, however, that many of these factors remain deeply uncertain, and thus the equation serves more as a framework for discussion rather than a definitive answer. Still, it elegantly captures the complexity and rarity involved in the cosmic emergence of technological civilizations. The beauty of the Drake equation lies in its invitation to explore each stage of cosmic evolution with scientific curiosity and rigor. For example, recent advances in astronomy have illuminated the abundance of exoplanets, revealing that planets orbiting stars are common throughout the Milky Way. This discovery has shifted estimates for the number of potentially habitable worlds, suggesting that the first few factors in the equation may be more generous than previously thought. Yet, as we move further into the equation, the uncertainties grow. The fraction of planets where life actually arises and then evolves into intelligent beings capable of communication remains profoundly speculative. The absence of concrete data in these areas has led to a wide range of predictions, from many civilizations scattered across the galaxy to a lonely Earth in a vast cosmic wilderness. This uncertainty underscores the importance of the Great Filter concept, which proposes that some step along this chain is exceptionally difficult to surpass, thereby explaining why we have yet to detect others. The Great Filter hypothesis intertwines closely with the Drake equation by suggesting that one or more of its parameters represent near impossible hurdles that most life fails to overcome. This filter could lie in the emergence of life itself, the leap from simple organisms to complex multicellular life, or the development of intelligence and technology capable of interstellar communication. It may even exist in the endurance of civilizations, as self-destruction through environmental collapse, war, or technological hazards might prevent long-term cosmic presence. The silence of the cosmos could be a reflection of this bottleneck, where many worlds begin the journey toward life, but few complete it. Consequently, the Drake equation, when considered alongside the Great Filter, provides a poignant framework for understanding why the universe might appear so quiet despite its vastness and potential. In contemplating these cosmic probabilities, we are reminded that the search for extraterrestrial intelligence is not merely a technological endeavor, but a profound philosophical inquiry. The Drake equation encourages us to examine the chain of events that lead from star formation to intelligent life, while the Great Filter invites us to consider our own fragile triumph over cosmic odds. As we refine our methods of detection and deepen our understanding of life's origins, each factor in the equation becomes a window into the unknown. The silence that greets us may be a testament to the rarity of our own existence, a call to cherish the delicate balance that sustains us on this pale blue dot. With this perspective, we turn toward the ongoing search for signs beyond our world, mindful of the challenges the cosmos may hold. As we ponder the vast silence that stretches across the cosmic ocean, one unsettling possibility arises. Advanced civilizations may be prone to self-destruction before they can make their presence known. The Great Filter, a theoretical barrier in the progression from simple life to interstellar colonization, may lie not in the distant past or the far reaches of the universe, but rather within the fragile trajectory of intelligent beings themselves. Throughout history, humanity has witnessed the profound consequences that arise when technological prowess outpaces wisdom and restraint. Nuclear weapons, once a symbol of ultimate deterrence, also embody the existential peril of annihilation. The delicate balance of peace and power teeters on a knife's edge, reminding us that the capacity for self-destruction is an ever-present shadow. Such existential risks highlight the sobering reality that the path to longevity as a civilization is fraught with peril, and that the silence we observe in the cosmos may reflect this universal challenge. Beyond the immediate dangers of weapons of mass destruction, other forces threaten the sustainability of advanced societies. Climate change, driven by the cumulative impacts of industrialization and environmental neglect, serves as a stark example of how progress can inadvertently undermine the very conditions necessary for life. Rising global temperatures, loss of biodiversity, and shifting ecosystems challenge the resilience of civilizations and their ability to thrive over extended periods. If such patterns are common across intelligent worlds, it could mean that many species face a narrowing window between technological emergence and catastrophic collapse. This perspective invites a humbling reflection on our own stewardship of Earth, emphasizing that the Great Filter is not merely a theoretical construct, but a call to conscious responsibility. The silence beyond our skies may be a quiet echo of civilizations who, like us, have confronted profound challenges with uncertain outcomes. Another domain of existential uncertainty lies in the realm of artificial intelligence and emerging technologies. As civilizations advance, they increasingly harness the power of autonomous systems and complex algorithms, which hold immense promise and peril. The development of superintelligent machines could redefine the trajectory of life, yet it also introduces unpredictable risks. Misalignment of goals, unintended consequences, or the rapid acceleration of capabilities beyond human control may contribute to scenarios where civilizations inadvertently hasten their own decline. The Great Filter may encompass this delicate phase of technological maturation, where wisdom must guide innovation, lest it become a catalyst for extinction. Such considerations deepen the enigma of cosmic silence, suggesting that intelligence itself carries inherent vulnerabilities that few civilizations survive intact. In this light, the absence of detectable extraterrestrial signals may be a reflection of universal challenges that transcend individual worlds. It is also worth contemplating that the Great Filter may not be a singular event, but rather a sequence of hurdles that civilizations must overcome to endure. From mastering sustainable energy use to establishing social cohesion and ethical governance, each step demands a delicate balance of knowledge, cooperation, and foresight. Failure at any of these stages might result in collapse or stagnation, effectively terminating the potential for interstellar communication or travel. The cumulative weight of these existential threats paints a picture of the universe as a vast landscape of fleeting sparks, intelligent lives that briefly illuminate the darkness before fading away. This view encourages us to approach our own society with humility and care, recognizing that our survival is neither guaranteed nor trivial. The stillness of the stars thus serves as a poignant reminder of the immense challenges that await any civilization seeking to endure beyond its cradle. Contemporary research into the risks facing advanced civilizations offers profound insights into why the cosmos might appear so silent. Scholars dedicated to the study of global catastrophic risks have identified a multitude of existential threats that could impede or abruptly end a civilization's progress toward interstellar communication or travel. These threats range from natural phenomena, such as supervolcanic eruptions and asteroid impacts, to anthropogenic dangers, including nuclear warfare, environmental collapse, and runaway technological disasters. By rigorously analyzing these factors, researchers aim to understand how likely it is that a civilization can navigate these perils and continue to thrive. The sobering conclusion is that the threshold for survival is remarkably narrow, and the probability of passing through this gauntlet unscathed may be low. This body of work lends scientific weight to the idea that the Great Filter, whether positioned in our past or ahead in our future, represents a formidable barrier to cosmic longevity. The silence of the stars thus may reflect not a lack of life, but the overwhelming difficulty of persisting through these profound challenges. One particularly influential area of study examines the fragility of social and technological systems under stress. Complex societies rely on intricate networks of resources, communication, and governance, all of which must function harmoniously to avert collapse. Historical records on Earth, from the fall of ancient empires to more recent systemic crises, underscore how interconnected vulnerabilities can cascade into widespread failure. Scientists and risk analysts extrapolate these lessons to civilizations beyond our planet, hypothesizing that any advanced society faces analogous challenges. The accumulation of environmental degradation, resource depletion, and internal conflict might repeatedly push civilizations to the brink, if not beyond it. This research helps explain why the universe might seem devoid of extraterrestrial signals or artifacts. Many civilizations could have been extinguished before achieving the technological milestones necessary for interstellar outreach. Such studies emphasize that survival depends not only on technological prowess, but on ethical stewardship and resilience in the face of uncertainty. Moreover, interdisciplinary approaches have broadened our understanding of how rare and delicate the emergence of long-lasting civilizations might be. Insights from evolutionary biology, astronomy, and sociology converge to suggest that even the initial steps of life-developing intelligence, followed by the cultivation of stable, cooperative societies, are fraught with difficulty. The Great Filter hypothesis gains empirical support from models showing that many evolutionary dead ends could lie along the path toward advanced civilization. Coupled with the examination of potential self-inflicted catastrophes, such as uncontrolled artificial intelligence or bioengineered pandemics, this research frames the Great Filter as a complex web of risks. Each civilization, in essence, must thread a narrow path through a landscape littered with hazards, any one of which could spell final extinction. The absence of detectable extraterrestrial civilizations may thus reflect the cumulative effect of these challenges, rather than any lack of cosmic ambition or curiosity. This perspective urges us to carefully consider the delicate balance we must maintain to avoid joining the silent majority. Beyond the internal challenges faced by emerging civilizations, the cosmos itself poses formidable and often unpredictable threats. Catastrophic events such as massive asteroid impacts or intense gamma-ray bursts represent powerful external forces capable of extinguishing life on a planetary scale. The history of Earth offers a somber illustration. Mass extinction events, like the one that ended the reign of the dinosaurs, remind us how fragile complex ecosystems can be when confronted with sudden, violent disruptions. These cosmic catastrophes do not discriminate. They act as impartial agents of change, reshaping the biological landscape and resetting evolutionary progress. In considering the Great Filter, it becomes essential to weigh the probability and frequency of such external hazards, as they may act as recurring roadblocks that prevent civilizations from advancing beyond certain critical thresholds. The silence we perceive in the universe could, in part, be explained by the relentless pressure of these external dangers, which cull the field of potential intelligent life before it can fully flourish. devastating cosmic threats are gamma-ray bursts, intense flashes of high-energy radiation emitted during cataclysmic stellar events. Though rare, these bursts can irradiate vast swathes of a planet's surface, stripping away protective atmospheres and causing widespread biological damage. For a civilization to survive and thrive, it may need to develop not only technological sophistication, but also protective measures against such distant, yet deadly phenomena. Similarly, the threat of asteroid impacts remains an ever-present risk within many planetary systems. While relatively small impacts may be frequent and manageable, a collision with a large enough body can trigger mass extinctions, climate upheavals, and profound disruptions to planetary habitability. These cosmic hazards form a backdrop of uncertainty and danger, shaping the evolutionary narrative of life and possibly limiting the emergence of advanced technological societies. The Great Filter may thus include the necessity to endure or mitigate these astronomical threats, a feat that requires both awareness and resilience. The interplay between cosmic catastrophes and biological evolution also invites reflection on the timescales involved. Planets and life forms must persist through eons of relative calm, punctuated by episodic disasters, each event carrying the potential to halt or reverse progress. This dynamic creates a precarious balance where even a single cosmic calamity could erase millions of years of evolutionary advancement. Consequently, the rarity of long-lived civilizations may stem not only from internal challenges, but also from the relentless unpredictability of the universe itself. The absence of signals or artifacts from other civilizations might indicate that many have been extinguished before they could leave a lasting imprint. Understanding the role of these external filters draws attention to the cosmic environment as an active participant in the saga of life, rather than a passive backdrop. Recognizing cosmic catastrophes as a critical component of the Great Filter encourages a broader perspective on planetary stewardship. Humanity's own survival may depend on anticipating and preparing for such external dangers, whether through the development of early warning systems, planetary defense initiatives, or space-based technologies designed to mitigate incoming threats. This awareness underscores the interconnectedness of cosmic events and the fragile thread upon which intelligent life hangs. It also deepens the mystery of why the universe appears so silent. The road to advanced civilization is not only littered with internal obstacles, but also shadowed by the unpredictable hand of cosmic fate. As we continue to explore these themes, the next consideration lies in how self-inflicted risks might compound these external threats, shaping the future trajectories of civilizations. The concept of the Great Filter emerges from the profound silence we encounter when we search the cosmos for signs of other intelligent life. Despite the vast number of stars and potentially habitable planets scattered across the universe, the absence of detectable civilizations suggests that there must be some formidable barrier that prevents life from advancing to a stage where interstellar communication or travel becomes common. This barrier, known as the Great Filter, could exist at any point along the path from simple organic molecules to advanced technological societies. It raises a pressing question: is the filter behind us, meaning that we have already navigated the most challenging hurdles of development, or is it still ahead, threatening to halt our progress before we can join a broader cosmic community? Understanding our position relative to this filter is not merely an academic exercise. It touches upon the very essence of our future and survival. If the filter lies ahead, it could mean that civilizations tend to self-destruct, succumb to environmental collapse, or fail to overcome existential risks. On the other hand, if we have surpassed this filter, then our civilization might be among a rare class of life that has managed to break through, making the silence of the universe even more poignant. This duality adds a layer of existential curiosity and urgency to our exploration of both the cosmos and ourselves. One of the most compelling reasons to believe the Great Filter may be behind us lies in the improbable emergence of life itself. The transition from non-living chemistry to the first self-replicating cells is an event so complex and rare that it might represent the single most difficult step in the evolutionary chain. If this is true, then the silence of the stars reflects not a failure of civilizations to endure, but rather the scarcity of this initial spark of life. From the formation of Earth to the advent of multicellular organisms, each stage presents its own challenges, but none as insurmountable as the origin of life. Our existence, therefore, might be a testament to the successful navigation of this profound obstacle. However, this perspective carries with it a sense of isolation, as we may be among the very few, if not the only, examples of life that has managed to progress beyond this primordial hurdle. Yet, even if life is rare, the path from simple organisms to technological societies is fraught with uncertainties. Evolutionary bottlenecks, mass extinctions, and the emergence of intelligence itself are all factors that could serve as additional filters. Determining where our species stands in this sequence remains one of the greatest scientific and philosophical challenges of our time. Conversely, if the Great Filter lies ahead of us, it implies that our civilization is approaching a critical juncture that few others have survived. The dangers of self-inflicted harm, nuclear war, climate change, artificial intelligence gone awry, loom large as potential candidates for this future filter. These risks are compounded by the fact that technological advancement accelerates faster than societal wisdom, creating vulnerabilities that could prematurely end our progress. The silence of the cosmos might then be a reflection of civilizations that, despite their ingenuity, fail to master the delicate balance between power and responsibility. This possibility urges deep reflection on how humanity manages its resources, technology, and global cooperation. Our ability to recognize and mitigate these existential threats could ultimately determine whether we join the ranks of long-lived civilizations or become yet another silent echo in the cosmic void. Awareness of these potential filters encourages careful stewardship of our planet and technologies, emphasizing prevention over reaction. It is a call to embrace foresight and collective action as essential tools in navigating the uncertain path ahead. Beyond internal and external filters, some theories suggest that the Great Filter might be linked to the intrinsic nature of intelligent life and its interaction with the universe. It is possible that advanced civilizations choose paths that make them undetectable or uninterested in interstellar communication. Alternatively, the expansion of life might be limited by physical laws or resource constraints that we have yet to understand fully. Such ideas expand the scope of the Great Filter from a series of discrete obstacles to a more subtle set of cosmic conditions that shape the fate of civilizations. This perspective invites us to consider not just survival, but also transformation and adaptation on scales that challenge our current imagination. The absence of clear signals or contact from other civilizations thus may reflect a complex interplay of factors rather than a single catastrophic event. It broadens the mystery of our place in the universe and the nature of the filters we face. As we continue to examine the Great Filter, the critical question remains: have we already overcome the most difficult challenges that prevent life from flourishing across the stars? Or are the greatest trials still on the horizon? This inquiry not only shapes our understanding of cosmic solitude, but also guides our approach to preserving and advancing our civilization. The answer influences how we prioritize scientific exploration, technological development, and the safeguarding of our planet. Recognizing the stakes embedded in this question encourages a sense of humility and responsibility as we navigate the unknown. Moving forward, it becomes essential to explore how both external cosmic forces and internal human decisions will shape the trajectory of our species, illuminating the path toward a future that may yet transcend the Great Filter. If the Great Filter lies behind us, it suggests that the most formidable barriers to the emergence of intelligent, spacefaring civilizations have already been surpassed. Perhaps the leap from simple microbial life to complex multicellular organisms, or the development of stable, technologically capable societies, represents a rare cosmic bottleneck. This perspective offers a subtle optimism amid the vast silence of the galaxy, implying that life like ours is incredibly special and uncommon. We may be living beyond the point where most potential civilizations falter, which could explain the quietude of the stars. The absence of alien contact, then, is not an indication of absence of life in general, but rather a reflection of the extraordinary conditions required to reach this stage. Such an outlook encourages us to appreciate the delicate chain of events that led to our existence, and to recognize the fragility and rarity of these successive evolutionary milestones. It also fosters a renewed respect for scientific endeavors aimed at understanding our origins and the complex interplay of chance and necessity that has allowed us to become observers of the cosmos. In this light, the vast cosmic silence may not be a sign of terrifying futures or imminent doom, but rather a testament to the rarity of advanced civilizations. If the filter is behind us, it implies that we have passed through a gauntlet of challenges that most life never even begins to face. These could include the emergence of life itself from non-living matter, the evolution of intelligence, or the ability to harness energy on a planetary scale without self-destruction. Understanding that such hurdles are rare offers a profound sense of perspective on our place in the universe. It suggests that while other worlds may harbor simple life forms, the complex civilizations capable of exploring the stars and communicating across light years are few and far between. This realization invites a humble appreciation of our achievements and a cautious optimism about the future possibilities that lie ahead. It also underlines the importance of nurturing our civilization to ensure we do not become the next filter for ourselves. The notion that the Great Filter is behind us has important implications for how we approach the search for extraterrestrial life. It may explain why efforts to detect signals or artifacts from alien civilizations have so far been inconclusive. If advanced life is exceedingly rare, the galaxy may simply be quieter than we once imagined. This quietness is not a void, but a canvas upon which our own story unfolds, highlighting the uniqueness of our journey. It encourages a shift in focus from the desperation to find others toward a deeper understanding of our own evolution and survival. This perspective fosters a patient, measured approach to space exploration, emphasizing long-term stewardship of Earth and careful contemplation of how we might one day extend our presence beyond our home planet. By embracing the possibility that we have overcome the most daunting challenges, we can move forward with a greater sense of purpose and clarity. Moreover, the idea that the Great Filter is behind us opens a window for optimism about humanity's potential. If the most difficult obstacles are in our past, then the future may hold opportunities for growth, exploration, and flourishing that few other species in the cosmos have experienced. This realization can inspire a collective commitment to avoiding self-inflicted catastrophes and fostering sustainable development. It encourages us to think carefully about how we use technology, manage resources, and protect the delicate balance of our planet. In this way, acknowledging the rarity of our survival so far becomes a call to action, a gentle reminder that we are custodians of a precious legacy that may never be replicated elsewhere. As we contemplate our next steps, we do so with a quiet confidence born of having already passed through the crucible of cosmic challenges. Yet, another perspective invites us to consider the possibility that the Great Filter lies not behind us, but ahead. If this is the case, the formidable barriers to advanced civilization and interstellar communication have yet to be encountered. Such a view suggests that the reasons for the apparent silence in the cosmos are not due to past failures, but rather due to challenges that intelligent life has yet to face. These could include existential risks that are currently unknown or underappreciated, threats that might halt or even erase civilizations before they reach a stage of widespread cosmic presence. This prospect invites a deep sense of humility and caution, reminding us that the path forward may be fraught with difficulties far greater than those we have already overcome. As we continue to advance technologically and socially, it becomes increasingly important to recognize that survival may not be guaranteed simply by past success or current progress. If the most significant filters are indeed ahead, humanity stands at a critical crossroads. The challenges that could represent this filter might be diverse and complex, ranging from self-destruction through nuclear warfare or uncontrolled artificial intelligence to environmental collapse or unforeseen cosmic events. The silence of the universe in this light becomes a somber reminder that many intelligent species may have reached a certain threshold only to vanish or be extinguished by these formidable obstacles. It encourages a reflective stance on our own development, urging us to carefully evaluate the risks inherent in our technologies and societal choices. Such awareness is essential not only for our survival, but also for the preservation of the potential to explore, to learn, and to perhaps one day join a cosmic community. It is a call for vigilance, fostering a mindset that values foresight and responsibility in the stewardship of our future. This perspective gently shifts the narrative from one of triumph to one of cautious anticipation. It suggests that while the universe may be teeming with life in its simplest forms, the emergence of lasting spacefaring civilizations is extraordinarily rare because the filters they face are yet to be passed. The weight of this possibility encourages us to look inward, to seek wisdom in our collective choices, and to cultivate resilience in the face of uncertainty. It is a reminder that the universe's quietness could stem from the fragility of intelligent life, and that our continued existence depends on our ability to navigate these unknown challenges. This realization places a quiet but profound responsibility on humanity to learn from history, to innovate wisely, and to foster cooperation on a global scale. In this way, the idea that the great filter lies ahead becomes not a source of despair, but a guiding principle for mindful progress. Contemplating the great filter as an unseen horizon beyond our current understanding invites us to embrace uncertainty with calm resolve. It encourages a patient, steady approach to scientific inquiry, technological development, and societal growth, one that balances ambition with caution. The silence in the cosmos may then be viewed as a protective veil, shielding us from prematurely encountering dangers that we are not yet equipped to face. Rather than diminishing our sense of wonder, this perspective deepens it, reminding us that the universe's vastness is matched by the intricacy and fragility of the path to advanced life. As we move forward, this awareness can inspire a collective commitment to safeguarding the future, nurturing hope that by recognizing and respecting these potential filters, we might transcend them. Such a mindset encourages us to listen carefully to the subtle signals around us and to prepare thoughtfully for challenges yet unknown. The silence we perceive in the vastness of space, often called the Fermi paradox, poses a profound question. If the universe is teeming with stars and planets, why have we not yet encountered signs of other intelligent civilizations? One compelling explanation lies in the concept of the great filter. This idea suggests that there are one or more critical stages in the evolution of life that are extraordinarily difficult to surpass. These stages may act as filters that few, if any, life forms outside of Earth have managed to overcome. The great filter could exist anywhere along the timeline, from the emergence of simple life to the development of advanced, spacefaring civilizations. As such, our own existence may be a rare and precarious achievement, balanced on the edge of these formidable barriers. When we consider this, the absence of observable alien life becomes less a mystery of cosmic neglect and more a reflection of the immense challenges inherent to life's progression. Among the possible filters, some are rooted in biology. The leap from single-celled organisms to complex multicellular life is one such hurdle. Others may be technological or societal, involving the ability to develop stable, long-lasting civilizations capable of exploring the stars without self-destruction. Catastrophic events, both natural and self-inflicted, could also serve as filters, wiping out burgeoning life before it reaches a detectable stage. These filters may be dispersed across time and space, making the probability of two civilizations coexisting and communicating exceedingly slim. Given the immense scales involved, it is conceivable that intelligent life is either incredibly rare or transient, fading away before it can reveal itself to the cosmos. This perspective invites a quiet humility, reminding us that our own technological and cultural achievements are just one step in a vast sequence that many others may not survive. The Great Filter also offers a lens through which we can interpret our own future. If the most difficult barriers lie ahead of us, it implies a need for vigilance and stewardship over our planet and technology. The silence from the stars could be a warning, an implicit message about the dangers that accompany progress. Conversely, if we have already passed the most daunting filters, our solitude becomes a testament to the extraordinary rarity of our existence, underscoring the preciousness of life and consciousness. Either way, the Great Filter frames the cosmic quiet not as a void, but as a profound narrative about survival, adaptation, and the delicate balance required to flourish in the universe. This understanding encourages us to continue exploring space with both curiosity and care, mindful of the lessons hidden in that silence. As we peer deeper into the cosmos and refine our methods of detection, the Great Filter remains a guiding concept that tempers expectation with patience. It suggests that the absence of contact is not necessarily a sign of emptiness, but rather a reflection of the complex and arduous journey that life must undertake. This narrative invites us to embrace the unknown with steady hearts, recognizing that the universe's quietude is an invitation to persist in our search, to refine our technologies, and to deepen our understanding of what it means to be alive. In this way, the Great Filter becomes not just an explanation for cosmic silence, but a framework for hope and responsibility. It calls us to listen attentively to the subtle clues the universe may offer, and to prepare thoughtfully and deliberately for the discoveries that lie ahead. In the quiet vastness of space, the search for extraterrestrial intelligence, or SETI, represents humanity's earnest attempt to reach beyond the boundaries of our world and connect with other potential civilizations. Using an array of radio telescopes and sophisticated algorithms, scientists scan the skies for signals that may carry the imprint of intelligent life. These efforts are marked by patience and precision, as the signals we seek, if they exist, could be faint, sporadic, or unlike anything we have encountered before. SETI's work embodies a profound curiosity, a willingness to listen deeply amidst the cosmic silence, and a recognition that the universe might communicate in ways that challenge our current understanding. Through these expansive surveys, we refine our technologies, improve our data analysis, and expand the scope of our search, ever mindful that even a single confirmed signal would transform our perception of our place in the cosmos. The Great Filter concept gently shades this search with a sober awareness of the difficulties any civilization must overcome to become detectable. It proposes that somewhere along the evolutionary path, from the emergence of life to the development of advanced technologies, there exists a hurdle so challenging that the vast majority of life forms may never pass it. This possibility adds a layer of complexity to our SETI efforts, as it reminds us that the absence of signals could be less about a lack of interest or effort from other civilizations, and more about the rarity of their survival or technological maturity. In this light, SETI's quest is not just an external search, but also a mirror reflecting the fragility and preciousness of our own existence. Each attempt to detect alien signals encourages us to contemplate the factors that have allowed us to endure and to consider the steps necessary to ensure our continued growth and resilience. As our instruments become more sensitive and our knowledge of the cosmos expands, SETI adapts by exploring new wavelengths, employing machine learning to sift through vast datasets, and collaborating across disciplines and nations. These efforts underscore a collective hope that somewhere in the cosmic expanse, a message awaits discovery, one that might offer insight, companionship, or simply the profound acknowledgement that we are not alone. Yet, the Great Filter remains a quiet reminder that such contact may be extraordinarily rare or distant in time. This gentle tension between hope and humility continues to inspire and shape SETI's mission, fostering a spirit of persistent inquiry grounded in scientific rigor and philosophical reflection. The ongoing search for extraterrestrial intelligence also invites us to consider the diversity of life and communication. It challenges us to expand our definitions beyond human-centric expectations, opening our minds to possibilities that may differ radically from our own experience. SETI's explorations encourage us to be patient listeners and imaginative thinkers, prepared to recognize forms of intelligence or signals that may be subtle, indirect, or encoded in ways we have yet to comprehend. This broadening perspective enriches the scientific endeavor and deepens our connection to the universe's unfolding mysteries, even as it acknowledges the sobering implications of the Great Filter. In embracing the quiet diligence of SETI, we participate in a profound journey, a search not only for others, but also for understanding ourselves more fully. The absence of clear signals so far does not diminish the value of this quest, but rather enhances its meaning. It calls us to persist in our listening, to innovate in our approaches, and remain open to the unexpected. As SETI continues, it invites us to gaze upward with steady hearts, ready to receive whatever cosmic whispers might one day emerge from the darkness. The concept of the Great Filter invites us to consider the many obstacles that life must overcome to reach advanced stages of development, perhaps even intelligence capable of interstellar communication. If we were to discover evidence of extraterrestrial life, whether microbial or intelligent, it would be a profound moment, reshaping our understanding of where this filter lies. Finding life elsewhere would suggest that the earlier steps in the chain, such as the emergence of simple organisms or the transition to multicellular life, might be more common than we once thought. This realization would gently nudge us to reconsider the rarity of these stages, implying that the filter might reside further along the path, perhaps in the leap to advanced technology or sustainable civilization. It is a humbling adjustment, reminding us that the universe, vast and ancient, might be teeming with life in ways we have yet to fully comprehend. Such a discovery would not only expand our scientific horizons, but also deepen our philosophical reflections on existence and persistence amid cosmic challenges. Conversely, if we were to detect intelligence signals or artifacts from distant civilizations, it could illuminate how some societies navigate or bypass the Great Filter. This knowledge would offer a rare glimpse into paths of survival and adaptation beyond our own experience, suggesting that advanced life can endure the perils that have so far eluded our own species. It might inspire hope that the challenges we face, environmental, technological, or social, are surmountable, lessons already learned by others in the cosmos. Yet, this would also raise new questions about the longevity and sustainability of civilizations, especially if these signals show signs of decline or silence. In such a case, the Great Filter might be less about the emergence of life and more about the fragile balance required to maintain it over cosmic timescales. The discovery would therefore become a mirror, reflecting possible futures for humanity and encouraging a deeper sense of responsibility toward our planet and our collective destiny. Our place in the universe would feel both less isolated and more interconnected, awakening a quiet reverence for the delicate threads that weave life through time and space. On the other hand, the continued absence of any definitive signs of extraterrestrial life could also carry profound implications for the Great Filter hypothesis. It might suggest that the filter is positioned early in the timeline of life's evolution, perhaps at the very origins of life itself, or in the transition to complex organisms. Such a scenario would imply that intelligent life is extraordinarily rare, if not unique to Earth. This rarity would deepen the sense of preciousness surrounding our own existence, highlighting the fragile miracle of conditions that have allowed us to flourish here. It would encourage a contemplative awareness of the silence that stretches across the stars, a quiet reminder of the vast challenges embedded in cosmic evolution. In this light, our efforts to understand and preserve life take on an even more sacred dimension, as if we are custodians of a singular spark in a universe of shadows. The Great Filter then becomes less a puzzle to solve and more a gentle call to cherish the delicate balance we have found. Whether the discovery of life elsewhere reveals that the Great Filter lies behind us or ahead, the implications ripple deeply through both science and philosophy. It challenges us to rethink our assumptions about progress, survival, and the nature of intelligence. It presses us to listen closely, not only to distant signals, but also to the subtle signs of resilience and fragility here on our own world. The search for extraterrestrial life, therefore, is inseparable from the search for meaning within our own existence, a dialogue between the cosmos and ourselves. Each potential finding, each absence, carries a lesson that invites patience, humility, and wonder. As we continue this exploration, we remain poised on the threshold of new understanding, ready to embrace the insights that await beyond the silence. This ongoing journey encourages us to gaze upward, not only with curiosity, but also with a steady, calm heart. The Great Filter stands as one of the most profound ideas in our attempt to understand the silence that envelops the cosmos. It suggests that somewhere along the path from simple molecules to advanced civilizations capable of interstellar communication, there lies a set of challenges so formidable that very few, if any, species manage to pass through them. This concept offers a possible explanation for why, despite the vastness of the universe and the billions of stars with potentially habitable planets, we have yet to detect clear signs of extraterrestrial intelligence. It is a reminder that the journey from life's origins to a thriving, space-faring society is not guaranteed. Instead, it may be a rare and fragile outcome, a delicate balance of circumstances and choices that determine whether a civilization endures or fades into cosmic obscurity. As we reflect on this, we come to appreciate the preciousness of our own existence and the incredible complexity of the processes that have allowed us to emerge and survive. Understanding the Great Filter also confronts us with profound questions about our future. If the most challenging barriers lie behind us, such as the emergence of life or the development of complex intelligence, then perhaps we have already passed through the narrowest gate, and our prospects for the future are hopeful. On the other hand, if the greatest obstacles still await us, challenges like self-destruction, environmental collapse, or the failures of sustainable expansion, then our silence might be a solemn warning. It compels us to consider our responsibilities with a new gravity, recognizing that our choices today will determine whether humanity becomes one of the rare exceptions or joins the countless civilizations that never reached a stage where they could communicate beyond their home world. This awareness invites a collective mindfulness about how we steward our planet, manage our technologies, and foster cooperation across borders and cultures. The Great Filter thus becomes not just a scientific hypothesis, but a call to consciousness, urging us to be both humble and hopeful custodians of life. The cosmic silence that has sparked the contemplation of the Great Filter is itself a profound mystery, one that touches on the essence of existence and our place in the universe. It forces us to reconcile the seeming contradiction between the abundance of stars and the absence of clear signals from other civilizations. In this quiet, there is an invitation to listen inward, to appreciate the miracle that life on Earth represents. It also encourages us to explore not only the heavens, but the depths of our own nature, seeking understanding of what it truly means to be intelligent, sentient beings capable of reflection and choice. The silence might be a space for us to grow wiser, to realize that the universe is vast and ancient, and that we are at the beginning of a story that is still unfolding. In this way, the Great Filter is not simply an obstacle, but a profound teacher, reminding us that the journey itself, with all its uncertainties and wonders, is a gift. As we stand on this threshold, gazing into the night sky, the Great Filter encourages a perspective that blends scientific curiosity with philosophical depth. It calls us to honor the intricate web of life and to cherish the rare opportunity we have to explore both the cosmos and ourselves. Our silence is not necessarily a void, but a canvas for imagination, hope, and the slow unfolding of knowledge. In acknowledging the possibility of the Great Filter, we embrace a future defined by responsibility and possibility, where each step forward is an act of courage and care. We are reminded that our actions today ripple through time, shaping the legacy of humanity in the vastness of space. This reflection invites us to move gently, yet purposefully, toward a future where the mysteries of the universe may one day be met with understanding, rather than silence. And so, our gaze remains steady, our hearts open, as we continue this remarkable journey among the stars.